There we go. Now we're recording. Oh, well, I guess you got to show up, right? All right. So again, this week was fire dynamics, just one chapter, but it's a lot of information. All right. So I'm just going to run through these with you, and hey, if you want to write stuff down, have at it. But I want you guys to know this stuff. So the difference between the fire triangle and the fire tetrahedron, right? All tetrahedron means is four sides. It means four-sided geometric shape, okay? Triangle, we all know what that is. That's three sides. So basically, we're describing fire theory in two different methods. One is a three-component method. The other is a four-component method. The fire triangle, the necessary legs to maintain combustion is oxygen, heat, and fuel. Three legs: oxygen, heat, and fuel, okay? And like I said last night, I think in the real world, particularly structure fire, that's going to be the model you're operating under normally. And the way we put out fires is we remove one leg of that triangle. In structure fire, usually heat by adding water, okay? So that's the fire triangle. And the fire tetrahedron has all the same three elements: fuel, heat, and oxygen. It just adds a fourth element or component, and that is the uninhibited chemical reaction, okay? And the idea behind that is, if combustion is an oxidation chemical reaction, it's a runaway oxidation reaction, which is a chemical reaction, okay? If fuel, heat, and oxygen are making this chemical reaction happen, another necessary component of that would be that chemical reaction is allowed to take place uninhibited. And the reason why that came out later on was because of the addition of chemical type extinguishing agents, so dry chems and halon clean agents, okay? And basically what you're doing in that case, the fuel, the heat, and the oxygen may be still present, but we're buffering that chain reaction, that chemical reaction. We're inhibiting it and not allowing it to take place. So it was a way for them to explain how these new extinguishing agents were actually working. So that's really the difference for you guys. The difference between the tetrahedron and the triangle is the tetrahedron adds that fourth element of the uninhibited chemical chain reaction, okay? Three methods of heat transfer, remember guys. Conduction is heat transfer through a solid object, okay? So something is hot on one side of the door, you touch the other side of the door, you can feel the heat, that's conduction, all right? And some materials conduct much better than others, right? Like a wood door conducts heat much less efficiently than, say, copper wire or an iron skillet, okay? So it would be one of the factors that affects conduction, all right? Convection, remember, is heat transfer through a fluid medium. So air or gases or vapors are fluid mediums. Liquids are fluid mediums. So like you can see oil simmering, you can see heat moving through oil as it simmers. That is convection. And that is basically created by the pressure and loft created by heat, right? Remember, hot air rises because of pressure, because by adding heat, we're exciting molecules, or we're creating pressure, and they're moving up and they're moving out through the environment, and heat is transferring with those super excited molecules. That is a heat conduction method, or a heat transfer method through a fluid element. It's called convection. And then the last one is radiation, right? Which is an electromechanical, and that is straight line. It does not need any kind of medium. It doesn't need solid, liquid, or gas. Radiation will work through a vacuum. We feel heat from the sun. It's radiated directly to us through vacuum to the earth. That's radiated heat. And it is straight line of sight. So, and you can disrupt radiation by breaking up that line of sight, particularly with reflective materials. So that's why when you look at a thermal imager, you can't see through glass, right? Because the glass is reflecting the heat back. All right, so that's radiation. So those three types would be conduction, convection. They both need some kind of medium. And then radiation is straight line, and it will even go through a vacuum. Okay. All right. So number 4, I think this one is pretty important. and that material can be found on page 165 to 176. It's the end of the chapter. And the question is to describe how building construction, and layout affect fire development, okay? And there's a lot there. I mean, it's almost 10 pages of material. But the important thing to remember is that the conditions that contribute to fire spread and intensity. So the building conditions that contribute to fire spread and intensity will also contribute to collapse. Okay, so particularly in modern construction. So when we think about modern constructions, it's oftentimes lightweight, has an awful lot of void spaces. Okay, these are conditions that contribute to fire spread. Void spaces gives fire places to move. Lightweight construction uses much smaller structural materials with much more surface area. And we talked about last night, increased surface area increases ignitability of a fuel, okay? So those are construction materials that or construction methods that make that building more susceptible to spread and intensify the fire, right? The fire is going to move through the building easier. It's going to catch those structural components on fire easier. And at the same time, because they're catching fire, is contributing to its capability to collapse. So you have a Venn diagram of fire spread and collapse capability meeting in the middle. And that, unfortunately, is a space that you're occupying when you're making an interior structural firefight. So remember that, pay attention to those 10 pages, read them carefully and understand what they're trying to say to you. Because again, one of the things that, you want to get out of this class is, I know, you might be away from making these decisions, but you want to be able to pull up on a building, see that it's on fire, and have some understanding of what's going on, where the fire's been, what it's doing now, where it's going to go. And then you can start to make informed decisions about how you're going to approach this situation. So your understanding of fire dynamics and building construction really, really inform that, and help you make those safe decisions about, okay, am I going to put people inside this building or not? Does it make sense? Is it a risk worth taking? So read those 10 pages carefully. Remember, again, that's 165 to 176. It's a lot of information, so do your best to answer number 4. But I think if you hit on that main theory there, that the conditions that contribute to fire spread and intensity will also contribute to collapse, and explain what that means, then I think you're basically answering the question. Okay. And then lastly, there's 28 terms here for definition. So they're all, I think, is there a glossary in the back of the book? You should be able to just answer it out of the glossary if there is one. If not, you can use the index.
Hey, Nick, the glossary is at the end of each chapter, and it has the terms for that chapter.
Okay, thanks. Yeah, so you can just, what's that?
I'm just saying there's a key terms section at the end of the chapter.
Oh, okay, cool. All right, so you can just use those to answer it. But if you want to look at this list, if you have any questions about it, I don't need that I go through all 28 of them right now. If you have a question about one of them, an idea you don't quite understand, I'm here. I want to answer it for you. Or you can send me an email. So auto ignition, backdraft, combustion. You guys understand the difference between endothermic and exothermic, what that means and how it applies to firefighting? Okay. I think that's a key understanding, that the fire itself is an endothermic reaction, pumping out energy and heat. We're using the endothermic reaction of converting water to steam to pull energy out of that system. And when we pull more energy out than the fire can produce, we are now extinguishing the fire. Okay. And so that's why, you'll hear us say, we just don't have enough water, right? Okay. The water is cooling, but we're not pulling more energy out than this fire is producing. We don't have a big enough line. Okay. So that's where you get the idea of big fire, big water. Okay. Heat release rate. I think it's important that you guys understand what that means. Okay. That is, like I tried to say last night, it's easy to think of heat release rate as the temperature at which something will burn. That is not the case. It's how quickly it gets to that temperature, right? So the example I used last night was like if you had a big wood ring full of firewood in your living room, that's a lot of potential energy. It would get pretty hot, but it takes a long time to burn all that firewood, right? Okay. But a couch cushion will ignite and begin flaming very, very quickly. It's not so much that it's going to get any hotter than that wood ring ever got or produce more energy in total than that wood ring ever did, but it got there much, much quicker. Okay. So that's the heat release rate. Okay. It's how quickly is it releasing the heat, right? Not what's the max amount of heat it releases, how quickly is it releasing it? Okay. Neutral plane, that one's really important. Just remember that when you're looking at a door, especially more specifically when you're looking at a compartment with a single inlet outlet. Remember, we're talking about flow paths again, cool air in, hot air, nasty air out, okay? If you're talking about a door to a room and it's the only opening, right? You're gonna have cool, fresh air being sucked in below, okay? And you're gonna have hot, nasty smoke being pushed out above, all right? Where those two meet, where that bottom end of that smoke line is and where that fresh air line is, that's the neutral plane, okay? And so when you're making those size up decisions and you see that front door, the further down that neutral plane is moving, okay, that's kind of like, I think of it as like a danger gauge, right? The further down it's moving, the more intense that fire is getting, okay? And the quicker we're getting to that ventilation limited or oxygen limited fire situation that we talked about in the VLS so much, okay? And the concern there is it has everything it needs in that fire triangle. It has the heat, and it has the fuel, it's just missing the oxygen, right? And it's still pyrolyzing, it's still making flammable vapors, it just needs oxygen. And what's one of the first things we do? We open up a door and move in to bring a line in, and we bring in a whole bunch of fresh air with us, okay? And so when we look at that time temperature curve, if you watch the VLS, definitely watch it. Pay attention to the time temperature curve. There's an initial spike where it gets to its initial fully developed stage. It becomes oxygen limited, starts to decay, and then there's a moment where everything inflects upward and goes way high. And that moment is almost always firefighter induced ventilation. So it's oxygen limited, and then we enter in the building, we bring oxygen with us, and it goes through the roof, and we're occupying that inflection space, trying not to get burned up as it goes into its new fully developed phase. So we need to be putting water on the seat of the fire, and we need to be controlling as much as possible how much oxygen we're allowing into that ventilation limited fire. So one of those indicators, again, on how close we are to being ventilation limited is that neutral plane. As it pushes down, and reaches the threshold, it begins to choke itself out, or the smoke itself is choking itself out. It's used all of its oxygen. Now we know we've entering into that very dangerous oxygen limited stage, where we might inadvertently interrupt that flow path or manipulate in a way where we're introducing oxygen and we aren't prepared to put water on the fire. So, pyrolysis, that's the process by which solid fuels off gas, all right, become vapors. Remember, only vapors burn. Solids are fuel sources, but only the vapors combust, okay? Some scientific terms here: solubility, specific gravity, that has to do with physical characteristics of liquids. Vapor density and vapor pressure, physical characteristics of vapors. Vapor density is how heavy is it compared to air. Vapor pressure is how quickly does it want to become a vapor. So gasoline has a very high vapor pressure, right? If you spill gasoline on the floor, it evaporates in a matter of minutes. It has a very high vapor pressure, right? Vaseline has a very low vapor pressure. It will take a very, very long time for that to evaporate. And then, yeah, ventilation limited, okay? Really understand that. That's really key. And when we talk about fire tactics and flow paths, our understanding of what ventilation limited means is really, really what dictates the tactics that we take, okay? So that is today, this week's homework. I think I helped you cover it pretty well, what we're looking for. Does anybody have any questions about the reading material or the VLS or anything at all? Because I'm here. And you can always email me if you think of something later, you know. Everybody's
I
good?
just had a quick question. I noticed you kept mentioning the number for the NFPAs. Do we need to know that for the exam?
I really don't know. I mean, we don't get to see the exam, you know. I always feel like NFPA numbers are easy questions for them to ask you, so it's nice to know them if you got them. I wouldn't spend too much of my effort, you know, life trying to memorize them. But if you can write them down at least once, and if you just knew that the NFPA 1970s were you know, PPE, that might help you in the future. So, but I can't say for sure it's going to be in there. So I would bet that most of those scientific terms we were discussing, though, I would bet those are going to be there, you know. So anything else? No? Okay.
Hey, Nick,
Yeah.
in the request test section, I was looking in there. It has a test option for hazmat awareness once you finish that. Isn't that just a certificate thing, not a written test?
The HMA, I'm not really sure how that's, because I thought they got rid of hazmat awareness. And it's kind of like included in what you guys are doing now. I know that there's part of it you're doing. I don't have that answer for you. I'll have to get it. I'll look into
Okay,
it.
because I was just looking, I got the certificate for completing that course, but
Right.
it showed as an option when you look to request exam.
All right. So you need to know if there's a test you need to take for HMA.
Yeah, I just want to double check on that because if so, I'll just get that over with.
Okay. All right. I'll ask the question. I'll find out and I'll get it out to everybody. Okay.
Okay.
I have a question, Nick.
Yeah. What do you got?
So, I mean, they mentioned something about the homework process, I guess, being done incorrectly. I'm not sure if I fall into that category. I've just been answering the questions on the little portal that's there, and
Yeah.
essentially how I've been doing it. I don't know how else I can do it, but am I doing it right or am I doing it wrong?
No, you're doing it right. You can type it directly in there if you're choosing to. That's
Okay.
fine. Some people are doing it on a Word document and then they cut and paste it in. That way they can edit it or save it.
Okay.
You know, you do
'Cause
it
I mean,
however.
I have a computer, but I'm not really like computer savvy, so I don't even know where to go to like actually open up like a pad or whatever and kind of do the whole cut and paste. So I'm just typing it in there.
Yeah. If you go, generally, if you go over into your systems or preferences, you can find Word.
Okay.
Open a file in Word. It's pretty easy to do. Just new file, blank document, and then
Okay.
you can write whatever you want, and
Okay.
then you right click over the text and hit copy.
Okay.
But then when you put it into the text box on the assignment, it just doesn't support the right click. You just have to use the keyboard shortcut, which is Control V. So
Okay.
if you chose to do it that way, but the way you're doing is fine. So I wouldn't
Okay.
worry.
Okay. As long as I'm doing it all right, I'll
Yeah,
just
you're
keep-
good. You're good.
Okay. Thanks, Nick.
Hey, Nick, I think what he was referring to was that mass email that one of the online instructors posted or pushed out saying that I think it was that people weren't pushing submit enough times to actually submit the homework in.
That's your nephew, my
Okay.
friend.
Okay. Okay.
Yeah.
I know I'm hitting it enough where it is submitting. So
Yeah, I think it's like 3 times you have to submit it.
Yeah.
okay. Okay.
The only person in Cherry Valley, Charlie, that is not getting that is Liam. Liam is so I don't know what he's doing. Have a talk with him, and I'm not trying to sell him out in public, but dude, like it's going to be a problem, you know. So yes, you have to submit it. Yeah, it's like 3 times. Do you want
Right. You got to literally click it about 3 times.
I think what he's doing is
right.
he's getting to where it's saved, and he thinks it's done. Saved is not submitted. So yeah.
Got it. Okay. Perfect.
You guys are all fine.
Awesome.
Liam and I are going to have a discussion.
you want us to check them when we get
I got him. He's my neighbor.
Anything else?
Good.
So do you guys like this format where I went over last week's homework and I start over next week's? Okay, then that's the format we'll use from going here on out. So, and you know, if I give you answers, hey, bonus for showing up, right? So, okay. All right, anybody, anything else? Otherwise we'll end it. So,
Nope.
okay,
All
cool.
good.
I think next week will be a Thursday. I think I'm working next week on Wednesday. So just heads up on that. So, okay. All right, guys, thanks for showing up. You guys have a good day. All right.
Thanks, Nick.
See ya.
Thank you.